Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about our first demo for the actual Sharp native bridge. Now this is going to be more of a just quick demo. I'm going to go through some of the basic things. It's obviously pretty complicated how I have things set up, but the purpose of this video is for you guys, or for me to get feedback from you guys. I know some of you may not think that it actually helps, but if you guys give me a thumbs up on the actual video to let me know that you really liked it, or even you can say that you don't like it or what you don't like about it. Like if you don't like something, then explain, how it can be better and so on. So any feedback goes a million miles with me. And of course, it's pretty early stages anyway. So the earlier the feedback that I get, the better, so I can improve on this feature. Also, before we get started, I will also say that since this feature is pretty close to being done, I fixed tons of bugs with it. This is most likely going to be in the YouTube series, so we are going to learn how to hook a language and connect it directly to C++. So with that out of the way, let's get into the video. So what we're going to do is we're going to create our foo function. We create this function with this syntax, and we're going to need to load the library called libuntitled. Now, it used to be called foo_test_lib, but I'm just too lazy. Whenever I try to create this API, I basically just generate this, so I just made it the same name. So that is our DLL. Now, the load library function is going to determine whether or not our operating system is Windows or Linux, and it's either going to pull in a DLL or an SO file. So that's why I don't put the extension, and then we just call foo. So in order to implement this code, what you're going to need to do on the user side is you're going to need to create a main file, and you're going to want to have what's called a native mapping include. What this is going to be is this is basically going to be all of the code that we need for our Sharp native bridge. That's going to be everything that we need to work. So once we include that, then we want to, of course, use namespace std so we can output stuff. And now in this example, I'm just going to print out hello world. So I'm going to say cout hello, world. And we're just going to do that, and I'm going to put a inline here, and I'm going to put a /new line to end the line, and that's going to be our basic foo function. Now we're going to create a scope of app. Considering that the foo function is a global function, it's inside the app class. Now if it was inside of a class, then as I've said before, we would just put class name underscore name, and then put another comma, and then that's the scope. So it would be an app hashtag class name. But in this example, we don't really care about that. So we're going to do this. So what we want to do is go up here to build and just build this library. And oh, okay, I guess I forgot to implement the actual code. So what you want to do is I've added this feature to my compiler. Now all of this code is happening at a late stage in the compilation process, so we don't have to rehash old code that we've already gone over. But we want to basically click run, and we want to recompile this entire programming language again. So we want to recompile our source code. That's going to give us a generated folder. As you can see here, it brought a generated folder into this directory, and that's going to have three main files: native mapping.cpp, native mapping.h, and sharp mapping.cpp. So what we want to do is go here and delete all of these files because there's old data. Anytime when you update or change your code, you're going to have to update your native mapping files that are auto-generated. So I'm going to paste that stuff in here. I also have to go into the CMake file and add this code back because it removed it. And once I do that, then we're good to go. And I also have to update this API / ideally you want the SNB API to be in the same folder. It's in here for now because I can just like drag and drop the API. But yeah, so that's what that is. So once we do all of that, then we can successfully build, and we won't get any linkage errors for incorrectly trying to compile the code, as you can see here. So I'm going to take this DLL, copy that, and I'm going to paste this DLL here, overwrite the DLL. Then I'm going to go to the, why is it not loading? I'm going to open up the Sharp runtime system. So I'm going to click here, go to Sharp, and then run Sharp, and we should get hello world. There we go. So that's how we do a basic hello world. Now let's get a little bit more advanced. Let's return a simple value. So what I'm going to do is I'm going to create a X, and that's going to be a var, and then I'm also going to create a Y, that's also going to be a var, and it's going to return a var of a result. So I'm going to say print line result, result, is equal to, and then I'm going to inline this code here into the string and end it that way. And then we can actually see what the result is going to be at the low level. Now, if we go back to the low level, we're going to have to create a couple of arguments. So we're going to have to create a var of x and a var of y. And we're also going to have to return a var as well. Once we return a var, then we're basically just going to, I can do a couple different things. So I can say x plus gets y. So I can add x to y and then just return x. Doesn't matter, as long as you return a var, then you're fine. So let's actually see what the result of that is. So I'm going to go back here and recompile my source code. So I'm going to go back here, copy and paste those files back in. This is probably the only annoying part about doing this. And also, if any of you guys are wondering, yes, this code does work with my code obfuscation system. So, if you obfuscate certain functions, now obviously at the C++ level, you're going to have to pick and choose what you want to obfuscate because, I mean, otherwise it defeats the purpose of code obfuscation. But yeah, my code will work with the code obfuscation system as well as the JIT system. So it's going to be really nice, and we'll kind of see how all that connects together. So once we have all that, it looks like it built the API successfully. Let's scroll back down here, paste it back in, and override it, and then run the actual code. Now we should get a result is equal to 15. Why is it still saying hello world? Did I leave that code in? Yeah, I guess so. Okay. But yeah, so you can see hello world and then result is equal to 15. I added 5 plus 10. So, I mean, that makes sense. And then it just prints it out at the high level, whatever the value is. And then we're all good. Now, this is a bit of a weird way to do it. Another way you could do it is you could create a result variable. So you can create a var, call it result, and assign that value to creating a local variable. So we want to create a local field of a var, and now we have that field. We're going to say result is equal to x plus y. And then we can, of course, return the result, SULT. Now, I'm not going to compile this. It's going to give us the same result. It's just going to give us 15. But yeah, so this is another alternative way you can actually return data. So this is the most basic form of creating local fields in the language. Effectively, what this does is, as you call this native function, it's going to allocate a stack size of 2 elements because we have 2 fields, right? So you only need a stack size of 2. But when we try to create a local field, it's going to expand the stack size of that foo function from 2 fields to 3 fields. So that's kind of how it works. I am going to be coming up with standards with my Sharp native bridge, and it's basically going to state that you should create any local variables that you want to create at the very first part of your function or at the very top. That way we don't have any weird like stack issues. But now let's try something else. So let's try doing something a little bit more concrete. So let's say we have a string. So MSG of string, string. And let's say I create a string here and I print line, or here I'll just call foo, and I will pass in a str. And I'm going to create a string up here, str is equal to new string. Now this is going to be an empty string, so it's going to have no value. And then I'm going to say print line str. So I'm going to print out what the value of the string is at the low level and at the high level. So now if I do this, I also need to remove this as well. I'm going to go and compile this code. And while that's compiling, I'm going to go over here and we need to modify this. Now, when it comes to objects in the programming language, what we want to have is we want to use the object BJE. Yeah, we want to use the object type, and that's going to be an object of MSG for our message, right? Is that what I called it? Yeah, I mean, the local variable or the name of the local variable does not matter. You can mismatch. As long as the type matches, then you're fine. This is also void because we no longer return anything. Now we're going to need to access that message field. So we know this is going to be a string class. So if we go over here to the string class, that's located in my lib support 0.2.805, and that's going to be down here. So if we go here, we can see that the string class is a field of data. The data field is going to be the actual field that we're going to need to access when it comes to processing information. So you can see it is a type of an int underscore 8 or an underscore int 8. So we want to get that type of field. So what we want to do is we want to get a int 8 array. So I'm going to say underscore int 8 underscore array. and we're going to say data, and we're going to create an int8 array based on the data we get back. So we're going to get a underscore int8 array. I'm going to go down here. So once we get that, we want to get that from the MSG, or the message string class. We want to access the data field. Once we have that, then we can then say data, data is equal to hello, comma, world, with an exclamation point, and that's it. So we just assign that value, and now we can print it out at the low level. So we can say cout, and then we can say data at low level is, and once we print that, now we want to call a function called, what is it called? String from. Yep. So we want to call string from, and we want to pass in the data class, which is going to convert this data structure of an int8 array to a string, which can be printed out here in cout. Finally, we want to remove that code, and we want to actually build the data. So I'm going to go up here to the build, and where is it at? So it's build untitled. So we're going to build this API once more, then we can actually see what the result is. So let me go down here, paste that in, overwrite, then run the actual code. So let's see. Hopefully we should get, okay, so we have data at low level is hello world, and then we have hello world at the high level. So we're effectively printing out the value of the data class at the high level and the low level. And what's cool about this is that we are able to successfully assign this data field, this string here, by basically accessing the data field in the string class. And once we get back to the high level, when we call print line, we also access that data field later as well. So before we move to the next example, one more thing I will mention is that if you notice, the data field is private. At the C++ level, when you're down that low, I don't really care about whether you have access privileges to a certain field, because that's just a high-level construct, so the user can do whatever they want. And in my opinion, I think the user should have ultimate freedom at the C++ level, because there's a reason why you're using that language in the first place. So keep that in mind. Next, let's look at a nested field example. So let's say I create this class here. So I'm going to create a class called car, and car is going to have a field in it called style. All right, so I'm going to create a style, and the style is going to be a color of some sorts. And whenever we instantiate the car class, we are going to set the style to red. So I'm going to say style is equal to red. Now what I'm going to do is create a color enum, so enum, color enum, and I'm just going to create the red because we don't really need much more for the purposes of this example. So I'm going to do red, and that's it. So now I'm going to pass in that actual data. So I'm going to say car, C-A-R. I'm going to pass in the car object, and we want to access the name of the actual enum that we're going to be processing. So what I'm going to do is just do something a little simpler. I'm just going to create a new car object here. And what that's going to do is call this constructor, which is immediately going to set the style to red. So that way, when we get down to the low level, we can properly access that style. So of course, we need to go back here and recompile this. And while that's compiling, we can properly update the code. So now I'm going to have a car object, and it looks like I have some bugs. Why did it say, oh, okay, that makes sense. Recompile. So while we're kind of doing this, we're going to have a car object, and we want to access that data field. So, or that name field, I think it's called. So before we actually access that field, we need to figure out how we are going to access it. So obviously we have the style field, but if we go down to the enum class, we can see here that the enum class has a field in it called name. So that means that I'm going to have to say style.name. Again, it's a int8, so we can access it that way. So I'm going to put in car for car, and I'm going to say style.name. So literally, you can just put dot notation access directly into the field name, and you can easily access any field the way you normally do. So I'm going to remove this, and I'm going to just print out whatever data is. So I'm going to say the color of the car, car, is, and then we'll print out a string from the data field. Now it's actually technically called name, but it doesn't matter. You guys get the point. So let's actually delete this code again. And once I kind of get everything set up and right before I run it, I will be back. And like I mentioned, when it comes to accessing data, you're not, oh man, I actually just clicked the wrong thing. When it comes to accessing data in the low level with my sharp native binary, it doesn't matter what type of data you want to access. You can just, of course, cast the data to whatever you want to cast. So as we can see here, we have the correct answer. So the color of the car is red. So that shows that, this code's working properly and it's working in accordance with the high level. Everything looks to be fine. So there's that example. Finally, let's do one more example. So let's have another function. Let's define call underscore me. So this is going to be an example where we have, we want to call a function at the high level from C++. So what I'm going to do is call me and or actually, you know what? Let's actually put a message in here. So I'm going to say MSG, and it's going to be of type underscore int 8 array, and I'm going to print line whatever the message is. So I'm going to pass in MSG as the message, and once this function gets called, then we can properly do that. So I'm not going to pass anything into foo, so I'm going to let foo at the low level generate an appropriate message for an int8 array, and then we can see what happens. So if we go back up to our foo function, we need to update it once more. So we're going to just do this, and instead of actually creating an int8 array of data this way, instead of using the get, what we want to do is we want to create a local field of type int, or is it underscore int 8 underscore array. So we want to create a local field of type int8 array. We want to say the data is equal to hello world, comma, LD. Yep. And then once we do that, then we need to actually call the function. So in order for this to work, I actually have to compile this code first, which I probably should have did as I was writing the code. But this is really cool. This is one of these key features that I think is really going to make my language stand out. And again, if you guys provide absolutely any feedback, it will go a long way because I'm really looking to make this language something for people to remember and for it to not be a huge pain in the ass to interface with other programming languages like most languages are. So I'm going to go back and paste this code in one more time. Then we can see what happens. So here's the amazing part about this. When it comes to actually calling functions, it's like, as you guys see, like I'm trying to make it as easy as possible. For instance, if we wanted to call another function, another native function inside of this actual scope, we can just say import. We can import whatever module it's in. So, mod, whatever module. And if it's in a class, then we can say some class, right? So we can just import things simply by doing that. But since we're not really doing that today, I'm just kind of showing you basic stuff. All we need to do is just say, so we need to call the call me function. And to show you guys, if some of you guys haven't developed in the Java JNI interface before, this is how it looks. So as you can see already, this looks extremely cryptic. So this is how you would do it in Java. Of course, you have to include the JNI. But in my language, as you can see, it's a lot simpler. All you got to do is include the native mapping. You create a scope of whatever scope you're in, which makes total sense. And then you just create a normal C++ function. You don't have to do all this binding crap with like JNI export, JNI call, and all this other stuff. And another benefit with my programming language is that the time to interact with the interface is very slim. It's almost non-existent. My interface is pretty much stacked on top of the DLL. So once you're calling functions in DLLs, it's basically an immediate call. It's not going to have to go through all these hoops of abstraction to try to get to your actual information, because I know that in Java's JNI, there is a little bit of overhead when it comes to actually calling these functions. And yes, I do have overhead as well, but mine is, in my opinion, a lot simpler, as you can see from the way that things work. So the way that Java calls a function is you have to like get a JNI or a Java method ID by passing in the environment, whatever class that you're trying to call the instance of that function on, and then, whatever the name of the function is. And this just looks ridiculous. How would you do it in my language? Well, we have this call me function, and we need to pass it this in array. So you just say call underscore me, and you just pass it the data, and that's it. Like, so now we're actually going to see what actually happens. We don't have to like know how to push data on the stack or anything. We just literally call the function at the low level as if it was already there in the first place. So that's something really cool. So I'm going to compile this here. And I think we should just get the actual hello world message. So yeah, so let's take this. And it's going to be the last thing I'm going to be showing you guys. And if I run this one last time, you can see here that we get hello world. So it's pretty cool. I really like the API. And as you see, like, there's not that much code. Literally to run all of this stuff, I have two files called the sharp SNB API. And this is just my API file. I mean, it's pretty big, but it has a bunch of stuff in there to kind of make everything work. It is pretty complicated. We'll have to go over it at a later date. But I mean, there's two main files to like do everything. And then there's like a native mapping. So basically what my compiler does is it creates a mapping for every single function in the programming language. So literally, as you can see here, I have a scope of std enum class. You can call any function in the enum class and it just works. It's pretty awesome the way it works. And I mean, it's pretty much every single function in my entire code that's being compiled. So if I were to obfuscate the programming language, then I mean, all of these function names and the class names would be gibberish. But as you can see, it also supports generic classes as well. This one would be a loopable, BLE, of type std hashtag string. So as you can see, I do modify the names of the classes based on what type of characters that it has. I use $signs as a way to denote the less than and greater than symbol. So I know I've said it a couple times in this video, but guys, I really would appreciate it if you gave me any feedback. Hope you guys enjoyed the video. As usual, if you have any questions, you can always put them in the comment section below. And of course, if you guys would love to help support the channel, you can always head over to my GitHub repository at androidevcd/sharp. And when you do, definitely watch, start, and fork this repository. That's going to give this language a lot more visibility and let other developers know this language exists. Also, if you're curious about some of the stuff that I do on a daily basis, you can head over to the remastered branch. In there, I write some pretty decent commits, so you can kind of get a gist of what I've been up to without really having to look too much in the code. Also, by the way, I've just recently released the code for the native bridge. So if any of you guys are interested, you can just click on this commit and just kind of take a look in here to see what I've done. It took a lot of code to make this work. As you can see, it just keeps on going. But yeah, so go back. Also, if you guys are curious about some of the stuff that I've done in the past to the language as well, or stuff that I'm looking to add in the future, you can always head over to the docs folder. In there, there's two main files. There's a change list file. That's pretty much all the old stuff that I've done to the language, as well as the roadmap file that contains all that information, as well as new stuff that I'm looking to add in the future. So that's it for today, guys. As usual, if you're new to the channel, definitely consider subscribing, and until next time, I'll see you guys later.